In this lesson, I'm going to cover WSUS, the Windows Software Update Service. This is one of the most important services on any network. What WSUS allows me to do is centrally manage Windows updates for Windows 10, Windows 7, server operating systems, Microsoft Office, System Center, Exchange. Well, you get the idea. All Microsoft products, and even some non-Microsoft products like device drivers. I can centrally manage deploying those through WSUS. By default, all computers have a registry key that directs them to the Microsoft Update website. Your home computer, for example, when you download updates, your computer connects to and through the internet back to Microsoft Update, and it downloads those from Microsoft. Well, at work, let's say you have 500 PCs at work. If you need to download 2 megs worth of updates, you would be downloading 2 megs worth of updates 500 times over, once for each individual machine, if you don't have WSUS or some centralized update solution. So the purpose of WSUS, I don't want my client computers to individually connect to the network to download updates, service packs, and all of those things. Instead, I want them to connect to a server on my network. That server is going to be my WSUS server. So the way WSUS will work for us, you just change colors here. We'll try green. My WSUS server will connect through the internet up to Microsoft Update, and it will download all the updates. And those updates will live on my WSUS server. Now, WSUS itself, when you install this is just a server role. Same way we install our file services, Active Directory domain services, DNS. It's in the list with all those roles. So you install that on your server. Then when I configure this, as we'll see in a demonstration in a moment, I just tell this, connect to the internet through Microsoft and download all the updates and store those updates locally. Now, I want my clients to connect to this WSUS server, and I want them to pull updates from this server. So our 2 megs of updates I referenced, now they are downloaded through my internet connection a single time, and now they're stored on my WSUS server. The configuration of this, I don't have in the picture, so I'm going to draw a domain controller. We will go through group policy on the domain controller. I'll define the name of the WSUS in group policy. That tells my client computers they now need to connect to this, not to Microsoft Update to download updates. So that's how clients are directed to the WSUS server itself. The other thing I can define in group policy is the schedule. So if I want these computers to download updates at noon, whatever time I want, all that is defined in group policy. Now, WSUS is not a difficult thing to configure, but it does require you to go to a few different places to get it fully set up. One of the layouts for WSUS is a concept of upstream and downstream servers. So in this picture, similar to the graphic we just looked at, it just does not have as many things actually going on. I have Microsoft Update out on the internet. I'm going to say my headquarters location is in Washington, and I have a branch office in Seattle. In Washington, I configure my WSUS here to download all updates from Microsoft Update, then they get stored locally. Through group policy, likely what you would have in your domain, we'll have a few OU structures. So I'm going to say this OU here is Washington, and this OU at the bottom is Seattle. I would configure a GPO that applies to Washington. That GPO defines this WSUS server. So all my client computers in Washington, they process the GPO, and they know this is their WSUS server. In Seattle, I'll create another GPO. That GPO defines the Seattle WSUS. So all these client computers know that's their WSUS server. So the way this works now, an update is downloaded one time across my WAN link to my Washington WSUS. Then that update is actually pulled one time across the WAN link to Seattle. So only once is each update traversing my WAN link. Clients will download from a WSUS in their respective location. So I'm using minimal bandwidth to make this function. This is the ultimate in efficiency for deploying Windows updates. Now I do have a few options. One option, in Seattle, I can have this be a replica or a non-replica. Now, non-replica, some places Microsoft refers to it as an autonomous server, but that'd be the same as a non-replica. A time when I would want to use a replica server. Well, let's say Seattle has 300 computers. And in Washington, we have, I'm going to say 1,000. Seattle is not large enough to have its own IT department or anything like that. So I don't have a person in Seattle that's going to test updates or approve updates. What I know is I test updates in Washington. When I approve an update in Washington, it gets distributed to all the computers in Washington. When I deploy that update in Washington, I want the same update to be approved automatically in Seattle. If that's true, my WSUS in Seattle, I will configure as a replica WSUS. That simply means in Washington, if I approve an update, that update replicates down and it's already approved. So effectively in Seattle, this is an unmanaged WSUS. It's really a distribution point if I were to make it a replica. It just eliminates these 300 computers from crossing the WAN link to talk to the WSUS in Washington. Now, maybe you are a bit more decentralized than that. If you require decentralized administration, I would configure this in the autonomous or non-replica mode. That means updates are still downloaded to Seattle from Washington, but none of those updates are approved. So someone has to go through the WSUS in Seattle and decide which updates they want to decline, which updates they want to approve, and it would have to be a highly managed server. Strictly depends on how your environment is structured, what your needs are, what type of updates you're deploying. So many things factor in that decision. But in the interface, we'll see exactly how that gets configured. The minimum requirements to install WSUS are really not a concern. WSUS does require IIS, .NET Framework 4.6 or newer, and it does require a database server. This WID, or Windows Internal Database, is natively built in. .NET Framework is natively built in, and IIS is built into the server operating system. So when you install WSUS, all those components are loaded by default. The only thing not loaded, if you want to view reports, you need to download this Report Viewer Redistributable 2008 or newer. Well, newer, there is a 2012 version that we would actually download, but that's not a concern. Because if you're in WSUS and you try to view a report, if that has not been installed, it gives you a hyperlink that connects you to the internet, so you can actually automatically have it installed. The only thing not done for us, other than the report viewer, if I want to use a SQL server, I need to run SQL 2008 R2 Service Pack 1 or newer. This would require me to already have a SQL server on the network. All this does is tell WSUS that I want to use an existing SQL server. So that's not set up for us either. But if you use a Windows internal database, that's a non-issue. To summarize that, everything I need to run WSUS is natively built in. The minimum hardware requirements, minimum is the key word. We must have a 64-bit processor. Now that x64, that kind of goes without saying, because there is no 32-bit server operating system. Windows Server 2008 was the last 32-bit server OS. 2008 R2 and newer only come in 64-bit. Still a technical requirement, but nowhere would you not meet that. So 64-bit, 1.4 gigahertz or faster, 2 gigs of RAM or more. There is no chance you would deploy a server with 2 gigs of RAM, so that's not a concern for our configuration, really. And disk space, not really a concern either. 10 gigs at a minimum of disk space, but Microsoft does recommend 40 gigs just to store updates. The basic things we'll configure in the next lesson I have to configure my client computers to use the WSUS server. That's going to be done through group policy. I'll show you that in the interface in one moment. Through group policy, the things we can manage. I can determine when my client computers get updated, what day, what time of day. I can define that install schedule. I can control restarts of clients. There are several options in group policy. For example, if we deploy updates during working hours, I may not want your computer to automatically reboot during working hours. Or maybe I want to require a reboot at a very specific time, and I may not want to allow the user to postpone the update. All those types of settings can be managed through group policy. We also have, these two. Default computer groups and just work with computer groups themselves. In WSUS, I can define computer groups and I can deploy updates to computer groups. A WSUS computer group has no relationship to Active Directory in any way. It's not an Active Directory level group. It's just a way for me in WSUS to say, I want to create a group for these computers because I know they all need an update for Windows Media Player. Another class of device may need another type of update. So you create these groups to control which updates are going to be installed on which computers. Now these groups can be created in the WSUS console. We'll see that option in a moment. And they can be created in group policy. Group policy would be the preferred option because you can easily centrally administer that, and computers can automatically be assigned to a specific group. But we'll look at all that in the configuration in the next section.